So friends, we are now at the end of this chapter, gravitation, and here in this video we are going to discuss about the free fall. This is very important and interesting phenomena which is directly related with the gravitation and the gravitational force or acceleration due to gravity. So there are some parameters which are related here with the free fall. Let's see what actually free fall is and what happens when we have any object which we hold in our hand. Suppose I have this pen hold in my hand, and if I drop it down, then what happens? What are the forces when I keep the object in my hand and when I release it? Okay, so let's see. As we know, the gravitational force is everywhere and the gravitational force acts on every object. Okay, each and every object. So if I have a stone in a hand, that stone experiences the gravitational force. Along with the gravitational force, there is the force which balances the gravitational force. Actually, it opposes the gravitational force. How it opposes? Suppose I have the stone in my hand, I feel its weight. That weight is nothing but the gravitational force, but my hand is there to balance it or to oppose it. Okay, so collectively there are number of forces, and hence that stone is steady in my hand. If I release it, that means there is no balance and only there is the gravitational force or the gravitational pull on that stone. So it will drop down because there is only one force acting on that stone or the object, and that is the gravitational force. Hence we can say if we release the stone, it falls on ground only under the influence of gravity. There is only one force, and that is the gravitational force. There is no any another force. Such type of action or such type of behavior of the object which is only under the influence of gravitational force or the gravitational pull, we call it as a free fall. Free fall means, as we know, we try to be free. That means we don't want any condition or any binding. कुठलेही आपल्याला बंधन नको असतं. That is we call the free. Like सेम होतं इकडे की एखादा ऑब्जेक्ट असेल त्याच्यावरती फक्त एक आणि एकच, ते म्हणजे ग्रॅव्हिटेशनल फोर्स जर असेल, गुरुत्वीय बल असेल किंवा गुरुत्वीय त्वरणाच्या मध्ये तो ऑब्जेक्ट, ती वस्तू जर पृथ्वीकडे येत असेल फक्त गुरुत्वीय त्वरणामुळे किंवा गुरुत्व बलामुळे, तर त्याला मुक्त पतन, मराठीमध्ये मुक्त पतन, फ्री फॉल. पतन म्हणजे पडणे, फॉलिंग, म्हणून मुक्त पतन असं म्हणतात. दॅट इज द फ्री फॉल. म्हणजे आपण सपोज लिफ्टमधून जातोय वरती, 10व्या 12व्या मजल्यावरती आपण जातोय आणि अचानक लिफ्टची रोप असतो, वायर रोप, तो तुटला. दॅट लिफ्ट विल कम डाऊन. दॅट इज द फ्री फॉल. किंवा वर एखाद्या बिल्डिंगच्या टेरेसवरून आपण एखादा दगड खाली टाकला, तो खाली येताना आपण रिलीज केल्यानंतर तो ज्या फोर्समुळे येतो ते असतं ग्रॅव्हिटेशनल फोर्स, आणि तिथं जे बिहेवियर असतं त्याला आपण फ्री फॉल ऑफ द स्टोन किंवा फ्री फॉल ऑफ द ऑब्जेक्ट असं म्हणू शकतो. म्हणजे वरून जेव्हा वस्तू एखादी खाली येते त्याला म्हणायचं फ्री फॉल. ओके, मग आता फ्री फॉलमध्ये फ्री फॉल तर कळा म्हणजे काय की the motion or the behavior of an object under the influence of gravitational force only. But what happens to other parameters of the body which are associated with it? म्हणजे नेमकं काय की त्याची वेलॉसिटी, त्याच्यावरती इतर कुठले फोर्सेस असतात का, किंवा त्याला अपोज करणाऱ्या फोर्सेस नेमके कसे बिहेव करतील, किंवा त्यांचा एक्झिस्टन्स असेल का, असेल तर कसा, नसेल तर का नाही, वगैरे बरेचसे प्रश्न आपल्याला इथे पडतील. आपण थोडक्यात त्याच्याबद्दल डिस्कस करूया. की सपोज वेलॉसिटी ऑफ ऑब्जेक्ट अंडर द फ्री फॉल, म्हणजे वरून खाली ऑब्जेक्ट येतोय, मग काय होणार आहे, ऑब्जेक्ट होल्ड केलेला आहे. ॲट दॅट टाइम इट्स इनिशियल वेलॉसिटी 0. व्हेन आय रिलीज द ऑब्जेक्ट इट्स वेलॉसिटी स्टार्ट्स टू इन्क्रीज. म्हणून असं म्हटलेलं आहे इनिशियली 0 अँड गोज ऑन इन्क्रीजिंग as g increases. g increases म्हणजे that object is coming towards the earth, म्हणून g increase होते. If that object is going anywhere else, then we can't definitely say g increases. g कधी increase होईल, that object is coming only towards the earth and that is possible only in the free fall. म्हणून हे स्टेटमेंट केलेले आपण. Initially 0 and goes on increasing as g increases. What is initially 0? The velocity of object. Initially 0, and when it starts to move under the free fall, its velocity goes on increasing up to the surface of earth. Okay, and another important thing is that the force acting on that object. In the free fall, there is only gravitational pull or gravitational force, because free fall is possible with the gravitational influence only, otherwise no. At that time we are talking this phenomena, suppose in any medium, suppose on the earth. Okay, so we are talking about the behavior of object in the earth's atmosphere. Atmosphere means number of gases, that means there is a medium, particular type of medium is there. So in any medium there is frictional force and the buoyant or buoyance force of buoyancy or buoyant force is there. These forces oppose the motion of the object under the influence of gravity. buoyancy मराठीमध्ये त्याला प्लावकता असं म्हटलं जातं, की ज्याच्यामुळे वस्तू तरंगू शकतात. त्या मीडियमनं ऑब्जेक्टवरती अपोजिट डायरेक्शननं अप्लाय केलेला फोर्स. हे 8th स्टँडर्डमध्ये डिटेल तुम्ही शिकलेला आहात. जे एरोप्लेन किंवा हेलिकॉप्टर्स वगैरे आकाशामधून ज्या पद्धतीनं फ्लाय होऊ शकतात, त्याचं एक महत्त्वाचं रिझन असतं की फोर्स ऑफ बायोन्सी, किंवा पाण्यामध्ये डिफरंट साइजेस ऑफ शिप्स अँड बोट्स आर देअर. ओके, हे का फ्लोट होऊ शकतात, तर त्याचं रिझन आहे फोर्स ऑफ बायोन्सी, बायोंट फोर्स किंवा फोर्स ऑफ बायोन्सी. आणि दुसरं महत्त्वाचं, ऑब्जेक्ट जेव्हा वरून खाली येत असतो तेव्हा त्याचं त्या मीडियम बरोबर फ्रिक्शन होतं, आणि फ्रिक्शनल फोर्स हा ऑब्जेक्टच्या मोशनच्या अगेन्स्ट काम करतं. म्हणून इथे त्या फोर्सला विरोध होणार आहे, म्हणजे फ्री फॉलला तिथे थोडासा अपोज होणार आहे. 2 फॅक्टर्स आहेत, 2 पॅरामीटर्स आहेत, आणि हे 2 पॅरामीटर्स म्हणजे बायोंट फोर्स किंवा फोर्स ऑफ बायोन्सी अँड फ्रिक्शनल फोर्स, याच्यामुळे फ्री फॉलला अपोज केला जाईल. मग आपण थोडंसं जर इतिहासात डोकावून बघितलं तर गॅलिलिओने हा एक्सपेरिमेंट त्यावेळेस पिसा, म्हणजे आज पिसा हे शहर आहे इटलीमधलं, आणि तिथं एक असा झुकणारा मनोरा आहे, तिथं हा एक्सपेरिमेंट केला होता. आणि त्यावेळेस गॅलिलिओने काय केलं की 2 वेगवेगळ्या वस्तुमानाच्या वस्तू वरून खाली सोडल्या होत्या. आता त्या सपोज शिशाचे किंवा लेडचे गोळे असतील जड, पण एखाद्याला असा शंका पडेल की डिफरंट मास असलेले ऑब्जेक्ट जर असतील, म्हणजे फॉर एक्झाम्पल खूप हलकी वस्तू, कागद असेल किंवा फिदर असेल, आणि एखादी लेडची किंवा शिशाचा किंवा आयर्नचा चांगला भरीव गोळा असेल, तर त्या बाबतीत हा जर एक्सपेरिमेंट आपण ओपन स्पेसमध्ये केला, उघड्यावरती केला, हवेच्या घर्षणामुळे कदाचित आपल्याला ते एक्झॅक्टली बघता येणार नाही, बट इट इज पॉसिबल इन व्हॅक्यूम. तर त्याच्यासाठीची ह्या लेक्चरमध्येच, या व्हिडिओमध्येच लिंक तुम्हाला दिली जाईल. ती लिंक ओपन करून तुम्ही तो एक्सपेरिमेंट बघू शकता. तर फ्री फॉल इज पॉसिबल ओनली इन व्हॅक्यूम. हा गॅलिलिओने व्हॅक्यूममध्ये एक्सपेरिमेंट केलेला नाही. व्हॅक्यूममध्ये जो एक्सपेरिमेंट केला तो साधारण 2014, म्हणजे 5-6 वर्षापूर्वी हा पहिल्यांदा एक्सपेरिमेंट केला गेला. सो वी आर टॉकिंग अबाउट द फ्री फॉल experiment which was initially carried out by the Galileo Galilei, but there was no vacuum. As I have written, the free fall is possible only in vacuum. Galileo performed this experiment but not in vacuum. He performed that experiment in open space. तुमच्या पुस्तकामध्ये याच्याबद्दल इन्फॉर्मेशन दिलेली आहे. मग हा एक्सपेरिमेंट व्हॅक्यूममध्ये कोणी परफॉर्म केला? द नेम ऑफ फिजिसिस्ट इज ब्रायन कॉक्स. यू कॅन सर्च on the YouTube as free fall in vacuum, or the link is provided in this lecture also. You can go directly using that link to that video, or the link is also provided in your textbook. तर तो व्हिडिओ तुम्ही बघू शकता की हा एक्झॅक्टली फ्री फॉल हा फिनॉमिना आपल्याला कशा पद्धतीनं ऑब्झर्व करता येईल. आणि सगळ्यात महत्त्वाचं, द इम्पॉर्टंट थिंग इज दॅट as we studied the free fall means the behavior of the object or the motion of object under the influence of gravitational force only. So different examples we can have. On the earth we can study or we can perform various experiments to study or to understand the free fall, but we know the moon and all artificial satellites which are revolving around the earth in particular orbits under the influence of gravitational force only. There is no another force. So this can be the best example of free fall. So moon and satellites are also in the free fall. Got it? So if you want to make your notes, I will suggest take the information which is on the board in your notebook properly and expand it. So guys, as we are talking about the free fall, the phenomena and the parameters which are associated with it, as we discussed earlier, this is possible only under the influence of gravitational force, right? So let's try to calculate or make the analysis of the parameters associated with the motion of the object. Means exactly what? समजा आपण एखादा ऑब्जेक्ट घेतला, तो वरती टाकला, सपोज वी थ्रोन ए स्टोन इन अपवर्ड डायरेक्शन. आता तो तसा निघून तर जाणार नाही, तो खाली येणार आहे. इट विल डेफिनेटली कम टुवर्ड्स द अर्थ बॅक. अँड रिझन काय असेल? द रिझन विल बी द अर्थ्स ग्रॅव्हिटेशनल फोर्स, राईट? सो हाऊ इट कम्स बॅक and what will be the velocity when it goes upward, what will be the distance, what will be the time taken to reach the desired height, etc etc. याच्यावरती वेगवेगळ्या पद्धतीने प्रश्न पण विचारले जातात. So let's first clear one thing, that what happens to the acceleration and the velocity. We know object or a stone is thrown in upward direction. Suppose when object is thrown upward, its acceleration is negative. How it is negative? When object goes towards the certain height or it goes away from the earth. Object is going upward means object is going away from the earth, right? So in this case, object itself is under the influence of the force which is against the gravitational force, and hence the velocity or the direction of motion of the object is also in the opposite direction as that of acceleration due to gravity. Direction of acceleration due to gravity, because we earlier studied that small g or the acceleration due to gravity always directed towards the earth, and here what happens? The velocity of object and acceleration due to gravity has opposite directions, because when your object is going away from the earth, the acceleration on that object or the acceleration which that object experiences, that is again acceleration due to gravity, and therefore it reaches certain height and becomes steady and it comes back under the influence of gravitational force, because there is opposition to the motion of that object. Hence the direction of velocity and acceleration are opposite to each other. Acceleration, this acceleration is acceleration due to gravity. Remember, acceleration due to gravity and direction of velocity, this is the direction of velocity of that object, and this acceleration, this is the acceleration due to gravity. Both have opposite directions, and hence we write due to negative acceleration velocity of object decreases. So simple सा बात है. काय लक्षात घ्यायचं आपण की एखादा ऑब्जेक्ट वरती टाकल्यानंतर त्याचा वेग कमी होतो आणि तो परत खाली येतो. त्याचं कारण काय? ॲक्सलरेशन, निगेटिव्ह ॲक्सलरेशन. निगेटिव्ह ॲक्सलरेशन म्हणजे द ॲक्सलरेशन विच अपोजेस द velocity of moving object, and hence its velocity decreases, becomes zero, and it comes back. Okay, so let's calculate what will be the velocity of the object, how much distance the object will cover in certain time, how much time that object will take, etc etc. We know the Newton's kinematical equations. In 9th standard we studied all these three equations, right? So first kinematical equation is phi is equal to u plus at, second is s is equal to ut plus 1 half at square, and third is phi square is equal to u square plus twice as. We studied these equations in last standard, but here we have to use these equations for the calculation of the object's velocity, object's distance, the distance covered by the object, and the time, etc. The same things, but here initial velocity for every case is 0. This is the initial condition, u is equal to 0, and the object will work or object will behave under the action of gravitational acceleration. That means the acceleration A is equal to small g. This is the acceleration due to gravity. So these will be the transformations. Equations मध्ये हा बदल करायचा आपल्याला. व्हॅल्यूज ॲक्सलरेशनची व्हॅल्यू ॲक्सलरेशन आहे, पण ॲक्सलरेशन कुठलं आहे? ॲक्सलरेशन ड्यू टू ग्रॅव्हिटी, आणि इनिशियल व्हेलॉसिटी हा आहे आणि त्याची व्हॅल्यू 0 असेल. मग स्टँडर्ड इक्वेशन phi इज इक्वल टू u प्लस at असेल, तर त्याच्यामध्ये आपण u 0 घेतला आणि a ची व्हॅल्यू g घेतली. वी गेट phi इज इक्वल टू 0 प्लस gt, दॅट इज phi इज इक्वल टू gt. हे नवीन ट्रान्सफॉर्म्ड इक्वेशन आपल्याला मिळेल. phi is equal to gt. Second equation काय आहे? s is equal to ut plus 1 half at square. We know very well. S is the displacement, u is the initial velocity, t is the time required, a is the acceleration. Okay, symbols have their common usual meanings, but here again u will be 0 and a is equal to g. So this equation will transform as s is equal to 0 into t plus half gt square. So this becomes s is equal to 1 half gt square. This is again transformed equation, the kinematical equation under the influence of acceleration due to gravity only. That means this is only vertical motion, maybe upward or downward. And third is phi square is equal to u square plus twice as. In all three equations here, phi is the final velocity or the velocity of object after time t, after certain time interval. So this is the final velocity phi. We are calculating phi square is equal to u square plus twice as. Again u is 0 and a is equal to g. So this equation again becomes phi square is equal to 0 square plus twice gs. Finally this equation becomes phi square is equal to 2gs. So in all three equations the acceleration is the acceleration due to gravity and initial velocity of object is always 0. So we can calculate the final velocity of the object if other parameters are given. That means if we know the time, then we can calculate the final velocity. If we have given the final velocity, we will be able to calculate the time required to reach certain height. This can be calculated by second equation. So as we used these equations for a linear motion in previous standard, we can use the same equations to calculate the object which is moving under the influence of the gravitational acceleration or the gravitational force, or simply the object which is in free fall. We can calculate its parameters using these equations. Got it? So I suggest all of you to write down these equations or the content on the board, and you can expand in your own language. Hello friends, we will talk about the escape velocity. Escape means to be free from any influence or any bonding or the binding, right? So in this case, as we are talking about the gravitation, let's discuss about the escape velocity. What is this concept? So we know the basic things. For an object thrown upwards, its height depends upon its initial velocity. We know very well. For an object with its certain initial velocity, whatever it may be. So whatever be the value of initial velocity, it goes up to the certain height. If that velocity is more, the object will go up to more height. If velocity is little, the object will also attain the little height. Clear it? So the velocity is important, and which velocity? We are talking about the initial velocity of object. म्हणजे सुरुवातीला जो आपण त्याला वेग दिलेला असेल तोच, नंतर काय बदल होणार नाही. आफ्टर सर्टन मॅक्सिमम हाईट द ऑब्जेक्ट रिटर्न्स टू द अर्थ. ऑब्जेक्ट फेकला, त्याला काहीतरी वेलॉसिटी दिलेला आहे, विशिष्ट उंचीपर्यंत गेला, ऑब्जेक्ट गोज टू द सर्टन हाईट. मग काय होईल? द ऑब्जेक्ट विल रिटर्न टू द अर्थ. हाऊ अँड व्हाय? द ऑब्जेक्ट रिटर्न्स अंडर द इन्फ्लुएन्स ऑफ अगेन gravitational field or the gravitational force exerted by the earth on that object, and it comes back. In this case, when object goes up to high and higher heights, the value of small g goes on decreasing. We know at certain height it has some value, but when the object returns, again value of g increases. This is very important thing. That means if we increase the initial velocity of the object, whatever will be the increase in the velocity, the object will get maximum height. Here, if we increase the initial velocity of object, will also reach to the further more height, and so on. As we increase the velocity, as we increase the initial velocity, object will reach to the maximum height. If we again increase the initial velocity, the object will again get the maximum or more than previous height. तो खूप जास्त असा जास्त उंचीवर जाईल. But remember, to get that maximum height, we have to apply, or we have to keep in mind its initial velocity must be larger and larger. All right. आता पुढे काय होते? At particular value of initial velocity, object goes up maximum height and never returns to the earth. मग असं आपण जोरात एखादा, म्हणजे न्यूटनच्या मनात असा एक्सपेरिमेंट आला. हे खूप छान वर्णन मी मागे तुम्हाला सांगितलं, केमियागारमध्ये दिलेलंच आहे, की एखाद्या उंच पर्वतावरून आपण दगड वरती टाकला तर तो खालीच येणार आहे, आणखी जोरात वरती टाकला तर तो खालीच येणार आहे, खूप जास्त जोरात टाकलं तर तो खाली येणार आहे. पण असा एवढा त्याला जोर लावायचा की तो परत माघारी आलाच नाही पाहिजे. हा जोर लावायचा असेल तर फोर्स तेवढा अप्लाय केलं पाहिजे, आणि तेवढ्या वेगानं वी हॅव टू अप्लाय दॅट मच वेलॉसिटी on that object, so as to that object will fly off from the earth's gravitational field. Same here, at particular value of initial velocity, object goes up maximum height and never returns to the earth. तो परत आला नाही पाहिजे. मग त्याच वेलॉसिटीला, किंवा एका ही जी कंडिशन आहे, never returns to earth means that object will escape from Earth's gravitational influence or Earth's gravitational field. That object has to escape from Earth's gravitational field, and in that case, for escaping the object from Earth's gravitational field, we have to give that object much more velocity, and this velocity is known as escape velocity. In simple words, we can define this as the velocity of an object with which it is thrown. It is thrown means the object is thrown, with which it is thrown up so as to get escaped from Earth's gravitational influence is called escape velocity. म्हणजे अशा एवढ्या वेगानं ऑब्जेक्ट वरती टाका की तो पृथ्वीच्या गुरुत्वाकर्षण प्रभावाच्या बाहेर गेला पाहिजे. तो जो वेग असतो त्याला आपण एस्केप वेलॉसिटी, इन मराठी त्याला मुक्ती वेग असं म्हटलं जातं. मुक्ती, तो मुक्त होतो. It escapes, it becomes free from the Earth's gravitational field or the Earth's gravitational influence, right? आपल्याला माहिती आहे की फायनल वेलॉसिटी, आता गंमत अशी आहे की we want to reach the object at maximum height, at more height, आणि मग तिथल्या हाईटपर्यंत गेल्यानंतर त्या ऑब्जेक्ट कुठेतरी स्टेडी होणार आहे. ऑब्जेक्ट मस्ट बी स्टेडी, अँड व्हेन ऑब्जेक्ट बिकम्स स्टेडी after a certain height, its final velocity becomes 0. So we can use the third kinematical equation which is given by Newton. V square is equal to u square plus twice as. In this equation we have to use the conditions. V is equal to 0, the final velocity of object must be 0. तो कुठेतरी स्टेडी होईल. आता ते कुठेतरी म्हणजे नेमकं काय आहे ते आपल्याला बघायचं आहे. And a is g. Again the acceleration is nothing but the acceleration due to gravity. Remember. Therefore this equation becomes 0 is equal to u square plus 2 times g into s. I have written this g negative in the bracket because the velocity, the direction of velocity and acceleration are opposite. Therefore this is negative, the value is negative. And hence according to this equation we can calculate the distance or the height attained by the object if its initial velocity is known, if its final velocity is known. So the maximum height or the distance attained or distance covered by the object is s is equal to u square divided by 2 into g. I have written this equation in magnitude form only. Don't get confused about the negative sign. Okay, because when you will solve this equation, the negative signs will be there, and on both sides, if there will be the negative sign, will cancel out. So I have written the magnitude only. In this equation, u is the initial velocity. So that initial velocity is nothing but the escape velocity, the velocity with which the object is thrown up so as to get escaped from the Earth's gravitational field. And we can use the law of conservation of energy here to calculate the energies, to calculate the escape velocity, the magnitude of escape velocity of the object. We have to compare, now we have to compare the energy, total energy of the object if it is on this Earth surface and if it is at certain maximum height, say infinity, because हा जो v 0 व्हायचा आहे की नाही. If we want to v equal to 0, that is possible at the distance which is equal to infinity. So we will compare finally the energies of the object on the surface of Earth and at the infinite distance. So first of all, you try to write all the content on the board and prepare the notes in your own words. So friends, as we are talking about the energies of the object on the surface of Earth and at a distance, at a point which is at infinite distance from the surface of Earth, or simply at infinity. Clear? So as we studied about the object which possesses certain velocity which is equal to escape velocity. So for any object, if its velocity to be, or instead of saying velocity, its velocity is equal to escape velocity, but that object has to be free from the Earth's gravitational pull. So that object has to reach up to the infinite distance, because if some students will have the question, that question is that what happens to the gravitational force or to the gravitational field? We are talking about Earth's gravitational field. So what will be the maximum boundary or the limit for the Earth's gravity? So we studied the Newton's law of gravitation. It is universal law, and we also studied that is the inverse square law. That means in order to get the gravitational force due to Earth on any object equal to 0, we have to put that object at infinite distance. Gravity is everywhere. Earth's gravitational force is also everywhere. Only its intensity goes on decreasing. म्हणजे पृथ्वीचं गुरुत्वाकर्षण सगळीकडेच आहे, ते एक विशिष्ट मर्यादेच्या ते मर्यादेच्या नंतर ते नसतं किंवा ते शून्य होतं असं नाही आहे, तर त्याची तीव्रता कमी होते. इट्स इंटेन्सिटी गोज ऑन इन डिक्रीजिंग. पृथ्वीपासून जसं लांब जाऊ तसं ग्रॅव्हिटी, जसं की जीची व्हॅल्यू कमी होते तसंच द फोर्स ऑफ ग्रॅव्हिटेशन बाय अर्थ ऑल्सो गोज ऑन डिक्रीजिंग ॲज वी गो अवे फ्रॉम द अर्थ. मग हा जर पृथ्वीच्या गुरुत्वाकर्षण बल जे आहे, ग्रॅव्हिटेशनल फोर्स जे आहे, त्याचा प्रभाव जर शून्य करायचा असेल तर आपल्याला इन्फिनिटी, अनंत एवढ्या अंतरावरती जावं लागेल प्रॅक्टिकली, विच इज नॉट पॉसिबल. सो ग्रॅव्हिटी एक्झिस्ट एव्हरीवेअर. क्लिअर इट? सो वी हॅव टू कम्पेअर about the energies. Let's talk about the energies on the surface of Earth and at the infinite distance from the surface of Earth. First of all, we know the kinetic energy formula we studied in last standard. 1/2 m into v square. M is the mass which is not changing and velocity may change. So kinetic energy on Earth's surface is equal to 1/2 m into v square. Okay. Whereas the kinetic energy of the same object but at infinite distance. At infinite distance, the velocity of the object must be 0. Therefore, its kinetic energy will become 0. Okay. Second, the potential energy on the Earth's surface minus g times capital M. This is the mass of Earth. This is the mass of that object which we are talking about. And r is the radius of the Earth, or the distance of that object from the center of Earth. So we have the simple formula minus g times m into small m divided by r. That gives us the potential energy or the gravitational potential energy of that object which is situated on the Earth's surface. Or if it is up to certain height, 100 or 1000 kilometers, that may become r plus h. We already studied. What happens here for the potential energy of the object which is at infinite distance from the surface of Earth? It becomes, the formula is same, minus g capital M into small m divided by the distance is infinity. So r is equal to infinity, and anything divided by infinity is equal to 0. We know very well. So the potential energy also becomes 0. Now we have to talk about the total energy. The total energy is nothing but the kinetic energy and potential energy. I have written the energies in short form. The Ke for kinetic energy, Pe for potential energy, and T for total energy. Say E, or in your book it is written as E1. So E is equal to 1/2 mv square minus g times m into m divided by r. This will be the total energy. If you have given the magnitudes of the mass, velocity, and only mass and velocity of the object, other rest of the constants, you will be able to find the total energy of that object on the Earth's surface. Clear it? What happens at infinite distance? Let's see. We already found that the kinetic energy at infinity is 0. The potential energy at infinity is also 0. So total energy 0 plus 0 is 0. So for every object, if that object is at infinite distance from the Earth, its energy will be 0. Alright, so these formulas will be helpful to solve the numerical problems, and you will be able to make your own analysis by solving the problems. Some problems are given in your book, some solved problems are there. You must practice on there first and then try to solve unsolved problems. If you found any query, any difficulty for any concept in this entire chapter, you can make your healthy communication with your teacher, means me, right? So don't have any hesitation to contact with your teacher and get your all concept cleared. This is very important, and using the content which we have written on the whiteboard during the lecture, you take down and try to prepare your own notes. I wish all the best to all of you. Thank you.